Hi there. Today we're going to discuss add and subtract mixed numbers. What will we learn today? Today we're going to add mixed numbers, we're going to subtract mixed numbers, and we're going to solve real-world problems involving the addition or subtraction of rational numbers. I'm going to go through examples 1 through 4 on pages 300 to 302, so make sure you're following along in your book. Here's our first example. Find 7 and 4 ninths plus 10 and 2 ninths. Write in simplest form. This example, we're very lucky because we have these same denominators. Okay, so the first thing I'm going to do is I'm going to write this vertically. Okay, now when you're adding mixed numbers, um, first you're going to add or subtract the fractions. If necessary, rename them using the LCD, and then you're going to add or subtract the whole numbers and simplify if necessary. Here we don't have to name anything with the LCD because we have the common denominator 9. So 4 plus 2 is 6, and then 7 plus 10 is 17. And the last thing you want to do is make sure that it is in simplest form. 6 ninths can be simplified down to 2/3. So the answer is 17 and 2/3. Example 2, you can find this on page 300. Find 8 and 5/6 minus 2 and 1/3, write in simplest form. So again, I'm going to write this vertically. Now, since we don't have the same denominator, we're going to have to um, rewrite them using the common denominator. Okay, so again, I start with my biggest denominator, which is 6. I start writing down some multiples of it, and I see if the other denominators are divisible by these numbers. And actually 6 is both divisible by 6 and 3, so I can rename them using 6. Okay, so I did not change the denominator 6, so I'm not going to change the numerator. And I did change the denominator 3. I multiplied it times 2, so I have to make sure I multiply the numerator times 2. So 1 times 2 is 2. Now I can go ahead and subtract the fractions because they have the same denominator now. So 5 minus 2 is 3, and then 8 minus 2 is 6. So our last step is to make sure that we simplify, and 3/6 can be simplified down to 1/2. So our answer is 6 and 1/2. Here's example number 3. This involves subtracting when the second numerator is larger than the first numerator. There are two basic methods when you're doing this. The first method is to rename mixed numbers. Again, since 1/3 is less than 2/3, you have to rename the second fraction because you can't take away 2 away from 1. So I'm just going to show you this little diagram really quick. Um, we have 2, I'm sorry, 2 and 1/3, and we are renaming it. So if you're looking at this model, 2 and 1/3, okay, and what I basically need more of are the pieces of thirds. So I just basically took this one whole right here and I changed it to 3/3, okay? So that basically just means that I have 1, and then I have 3/3, and I have another 1/3, which is down here, and that equals 1 and 4/3, okay? Um, what I like to do personally is I like to say 1 and 1/3, 2 and 1/3. I like to say I'm going to borrow from the 2, so I'm going to make it 1. And if I borrow a whole number, I add to the fraction. So my whole number was 3/3, so that's why I get 4/3. Okay, so that's how I get 4/3. All right, so I'm just going to go ahead and rename 2 and 1/3 as 1 and 4/3. Let me just bring this down a little bit. 1 and 4/3 instead of the 2 and 1/3 minus the 1 and 2/3. Okay, and that just still equals 1 and 2/3. Okay, so now I'm able to subtract the 2 of them. Okay, now I can say 4 minus 2, and that equals 2. and the denominator is 3, and 1 minus 1 is 0. So your answer is going to be 2/3. Okay, now renaming is not for everyone. I'm going to show you a different way. I just really like the renaming because the second method is to rename everything as improper fractions. It's pretty okay with smaller fractions with smaller denominators, but if you get something like with a denominator of like 17 or 23, it might get a little bit difficult. So what we're going to do is take 1 2/3, oops, 1 1/3, 2 2 1/3, minus 1 2/3. Again, you're saying to yourself, I can't do 1 minus 2. So I'm going to change them all to improper fractions. So again, I'm going to say the denominator stays the same. So 3 times 2 is 6, plus 1 is 7. So 2 1/3 is 7/3. And then the denominator stays the same. 3 times 1 is 3, plus 2 is 5. Okay, so now I can do 7 minus 5. That equals 2/3. So either method that you use, the answer is going to be 2/3. You can choose whichever one you want. Most people like this version, um, but you just have to remember once you get an answer, you have to make sure it's back in simplified form. Okay, and here's our last example, example number 4 on page 302. An urban planner is designing a skateboard park. The length of the skateboard park is 120.5 feet. The length of the parking lot is 40 1/3 feet. What will be the length of the park and the parking lot combined? So again, the word combined here is telling us we're going to have to add. So we've got 120 1/2, adding to 40 1/3. Okay, and when we're looking at this, we know that they don't have the same denominator, so we're going to have to rename them. So 40. Okay, so we're looking at our denominators 3 and 2. I'm going to start with the biggest one, 3. I'm going to write a couple multiples of it. 3 is not divisible by both 2 and 3, but 6 is. So we're going to change it to a denominator of 6. We went from 2 to 6 by multiplying by 3, so let's go ahead and multiply the numerator and denominator by that. We got from 3 to 6 by multiplying by 2, so again we're going to multiply the numerator and denominator by that. So now we have the same denominator, 6. We can add 3 plus 2 now, and that's 5. And 120 plus 40, that equals 160. And the total length is going to be 160 and 5/6 feet. Okay, I hope that video was helpful. Thank you. Bye.